in the first class. This one, if you remember. Or should I revise it again?
No, sir. It's okay.
We can skip
Again.
it. Check it.
Yeah, yeah.
Okay, Nan. So, yeah. So now in this class, we are going to discuss about the next thing, that is your image. So in this chapter, Enaan will be talking about images. So it's very common that we should know that what image is basically and what are the types of image that we have to deal with. Okay. So first of all, Enaan, we have the image definition is basically the image is an optical appearance. Optical appearance means it is made when the light ray intersects. Okay. It is made when the light ray intersects. So that's why when the light rays going from one object are reflected or refracted from a mirror or through a lens. So image can be formed with the help of mirror. Image can form with the help of lens. Okay. So in the mirror, it would be reflection. In the lens, it would be refraction. Okay. Please do let me know, Enaan. Any doubt so far to you, please do let me know. Is that clear?
No, sir. No, sir.
Any clear?
Yes, sir.
Okay. Now we have two types of images, Enaan. First one is your real image. Second one is your virtual image. Okay. So what real image is basically, are you there, Anand, or are you taking any call?
No, sir. No, sir. I'm
Check, check.
listening.
Okay, no worries. Okay. So we have two types of images basically. First, we have the virtual image. Second one, we have the real image. So now let's talk about the real image first. So real image is formed in an when the two reflected light rays intersect at a point. So reflected light rays, we are talking about reflected light rays. Suppose that this is a medium. Okay. So this is a medium. So this one will be your reflected light ray, this one. Okay. And another light ray would be like this. Okay. So over here, this one is your reflected light ray. So at this point, these two are meeting. Yes or no, Inan?
Yes, yes, sir.
Right. So if they are meeting, Inan, so that's why it would be your image. Okay. So if the light rays are actually meeting, so such type of images are called a real image. Okay. Yeah. Okay. So
Yes, sir.
yeah. Okay. Next is Inan. Next property is real image is inverted in nature. That means suppose that Inan, if your object is like this, the image formed of the object real image that would be like this.
Okay, sir.
Okay. So its
Uh,
body upright, basically head would be upwards and it would be downwards. Clear, Inan?
clear, sir.
That's great. Okay. Now let's talk about the next thing. That is fourth is basically real image can be obtained on a screen. Suppose that Inan, when you click a picture through a mobile, so can you will you able to print that picture on a paper? Yes or no?
Yes, sir. Yes, sir. We
Yes,
can.
because that picture because basically you can say the person, the scenario, the surrounding exists in reality. Yes or no?
Yes, sir.
So that's why real images can be obtained on a screen. The images that we see on a theater, right? In the theater, the movies basically run. So basically, the movies are short. Okay, so basically, the person, the scenario, the action, everything is real. That's why we can obtain that thing on a screen. Okay, and one more thing, Inan, no need to worry. Every note will be shared with you. Okay,
Okay,
so
sir.
notes. I think you've already got the notes as well. Have you got the notes?
Yeah, yeah, yeah. I
So
have got
that
it.
yeah, that drive PDF is complete. Have complete notes. Okay,
Okay.
same notes. Okay, same notes. Just a
Okay.
way of writing is different, but the notes are same. The content is same. Okay.
Okay.
Next is Anand. Image form example of real image. Basically, image formed by the real eye is human eye is real image. Okay, the example of real image is the human eye. The image formed by the human eye. Is that clear?
Okay, sir.
Any doubt?
No. Image from.
Sure, that's great. Now let's talk about virtual image. Suppose that Anand, this is mirror. Okay, this is mirror. Okay, light is going like this and the another light ray is going like this. Okay, so these two are reflected these two are reflected rays, this one and this one. So are they meeting if you extend them in the backward direction, in the forward direction? They are not going to meet because they are going
Yeah.
spreading out like this. Yes or no?
Uh, yes, sir. Yes, sir.
Right. So what we do is that in An basically we assume that suppose they are starting from a common point that is behind the mirror. So such image is called virtual image because in this the lines are not actually meeting. We are just assuming that they are meeting behind the mirror. Clear, Inan?
Clear, sir.
Okay. So this type of mirror, this type of image is called virtual image. So in simple words, virtual image can be, you can say, referred to as illusion. Suppose that, Inan, you are basically thinking something in your mind, right? So in your mind and to you as well, it looks like that it's very real. Yes or no? But in
Yes, sir.
actually, is it real?
No.
No, that's not real. And after that, if we talk about one thing in Inan, will you be able to basically take that scenario on a paper just like the real picture?
No, sir.
No. So such images are called virtual images. That images actually does not exist in reality, but they assumed to be real. Okay,
Okay, sir.
that's great. So the properties of virtual image is basically this. Okay, let me tell you one thing as well. The property of virtual image is basically if the object is like this, so virtual image will always be like this. It would be upright. Okay,
Okay, sir.
and okay, virtual image will always be exactly same, just like of the object. Okay, Nan,
Okay, okay, sir.
that's great. Okay. So virtual image is formed when at least two reflected or refracted light rays appears to meet when extended. They are not actually meeting, they are appears to be meeting. Yes or no?
Yes, sir.
Okay, after that, virtual image is erect in nature. That I have told you, erect means upright. Virtual image cannot be obtained on a screen because they are not actual, they are just illusion. Next is image formed by a plane mirror is a virtual image. The mirror that we use to dress ourselves in our normal day-to-day life, that is a plane mirror. So the image formed by the plane mirror is virtual in nature. Is that clear, Inan?
Yes, sir.
Any doubt
So,
so far? Do you? Yeah.
so, so why the image formed by a plane mirror is virtual image and a real image? Like, what is the difference, sir?
In difference, you can say that the difference is basically on the basis of the intersection of light in Inan.
Okay.
It's basically if the light rays are actually meeting, that means it is real image. If the light rays are not actually meeting, they are assumed to meet, that is your virtual image. Is that clear, Inan?
Uh, okay, sir.
Okay. So now, okay, I'll show you the image formation of the plane mirror as well. Okay. So first of all, now let's discuss the image formation of plane mirror in Enaan first. Okay. So what are the different, you can say the plane mirror, acha, plane mirror, you can say properties. Sorry. Okay. You see this thing? Plane mirror property is basically the image formed by the plane mirror is same in size as that of object. Yes, that so suppose that now you are standing in front of a plane mirror. So the image looks like very exactly same replica of yours.
Like it is same, but it's in
Uh,
the point of view of myself, not the others. So it is.
that's I'm just right now I'm just talking about the height. We'll discuss that basically distance portion as well from the mirror as well. Okay. Right now you will see that that the size of your hand, of your face, everything would be exactly same as that of your body. Yes or no of the image.
Yes, sir.
Right. So this is the first property. Second property is in the image formed by the plane mirror is at the same distance. Suppose that you are standing 1 meter away from the mirror. You will see that your image will also be 1 meter away from the mirror. Basically, inside the mirror, you will see that the image is also 1 meter away from the mirror. Yes or no? That's what you are saying.
Yes, sir.
Yeah. So that is your basically the image distance and the object distance of the plane mirror is same. Okay, Nan.
Okay, sir. Understand.
Next is virtual the erect the plane mirror always formed upright and erect images. It will always form upright and
Uh,
erect.
like, what does that mean, sir? Can you explain a bit?
Upright
What?
erect means upright means like this. Erect virtual. If the image is virtual, that means it would be like this. Clear, Inan?
Like how? Like what does that mean? Like.
Does that means that if you're standing, when you stand in front of a mirror, your head appears in the top position, your body appears in the lower position. Yes or no?
Yes.
That's what I'm saying.
Okay.
Clear one? Any doubt?
Not also.
Okay, that's great. Next property is basically the lateral inverted images. So, okay. So the image formed by the plane mirror is laterally inverted. That means your right appears left in the mirror, and your left appears right, that property of the plane mirror is called lateral inversion.
So that is the thing I was talking about in the first.
Could you please repeat?
Sir, that point was the thing I was talking about when you asked about the plane mirror first.
Okay, so you were talking about the lateral inverted part.
Ah,
Acha, ठीक है. So this property is called lateral inversion. When you basically raise your right hand and basically raise your right hand, but in the image it appears your left hand, and left hand appears your right hand. Yes or no, Inan?
yes, sir.
Any doubt so far, Bacha?
Yeah, it's good.
Sure, that's great. Clear. Okay, so next is what is lateral inversion? The right side of the body becomes left side, and the left side of the body becomes right side. So this change of side of an object and its mirror image is called lateral inversion. Okay, Nan?
Ah, understood.
That's okay. Okay. So just a second. So let me write down the ray diagram of it. Okay. How to form the ray diagram? See this thing, Inan. Suppose that your object, you are standing. You are standing like this. Okay. You're standing in front of the mirror. Okay. So this is an
Yes,
object
sir.
that is standing in front of the mirror. So Inan, so basically how to draw the ray diagram of any object is basically there are two rays that needs to be drawn. First ray will be perpendicular, sorry,
Parallel.
parallel to the principal axis. Yes or no? So let me tell you
Yes,
why.
sir.
So see this thing, Inan. Suppose that if the light ray is perpendicular to the principal axis, sorry, it's basically parallel to the principal axis. What does it mean? So what is the angle of incidence? If the light ray is striking perpendicular to the plane mirror, what will be the angle of incidence, Inan?
The angle of incidence will be 90 degrees.
No, not 90. Why? Because see this thing, Inan. The normal is also 90. So basically angle between the normal and the incident ray decides the angle of incidence. So two parallel lines have 0 degree of angle. Got it?
Ah, okay, sir.
Okay. So if the light ray is having 0 degree angle with the normal, that means angle of incidence would be zero,
Yes, sir.
right? So if the angle of incidence is zero in an, so that means the light ray will basically retrace the path. Yes or no?
Yes, sir.
If it's
Yes,
going like this, it will go like this because angle is same.
yes,
And
sir.
out so far to you, Inan, please do let me know.
Uh, yeah, I understand.
Understood? That's great.
Understood,
So
sir.
now next is basically next ray should be like this. Next ray will strike the this pole, will strike the mirror at some angle. So Inan, if the light ray will strike the mirror at some angle, what is the angle of reflection? Will it be same or different?
Sir, it will abstractly like reflect.
It will reflect with the same angle, Inan, like this. Yes or no?
Yes, sir. Yes,
Right? Just a second, let me use it with the yellow color. Okay. So see this thing, Inan, these two light rays are reflected light rays. Are they gonna meet in the backward, in the forward direction? If you basically see this thing, are they meeting actually?
no, sir.
No. So what we have to think is basically we have to think that light rays are going, basically let's see, assume that light rays are intersecting behind the mirror. Suppose that they're originating from a behind the mirror. Yes or no, Inan?
Yes, sir.
Okay. So that's what I'm gonna take is basically. So I'm extending this line. Okay.
And okay,
Okay. So you will see this thing, Inan, that like yeah, actually they are meeting. Okay, they are meeting actually. See this thing.
sir. Like we are assuming, right?
We
They
are
are
just
not
assuming.
actually.
Yep, yep. We are actually just assuming that yeah, suppose they are meeting behind the mirror. Clear, Inan?
Clear, sir.
Any doubts so far, to you, Bacha?
No.
No. So this is basically your point of intersection. That means this is your image formation point. See this thing. So this is your image formation point. You see this thing, Inan, you will see that the image formed by the plane mirror is same size, is in same size of the object. See this thing, isn't it? Basically, so if you compare the image, see this thing, isn't it same?
Yes, sir. This, sir.
Right. Okay. Next thing I was saying that you are suppose you are standing any specific distance from the mirror. So that means the same distance is also behind the mirror as well. This
Yes,
basically is also proved. Yes or no, Inan?
yes, sir.
Okay. So basically, when the object is placed from the mirror, that distance is called object distance, Inan. Okay.
Okay, okay.
And when the image formed is basically whatever the distance between the image and the mirror is, that distance is called image distance. Clear, Inan?
Clear, sir.
That's great. Okay. So these are the basically the steps. You can write down these steps. Inan, please write down these steps. First, light ray should be drawn parallel to the principal axis. These are two. You can say that.
Sir, I should write these points now.
Yeah, these 2 points.
Okay, sir. Like these 2 points. Okay.
Hmm. Because these two lines are not there in that notes, so that's why.
Sir, can you scroll down a bit?
Ah, sure.
I can't
These
see
are
the
all.
second line.
Yeah.
Okay.
Done, Inan. Just give me a second. Let me do one. Just
Anand,
give me a
sir.
second. Inan.
Uh,
That's right. Just give me a second. Please try to solve these questions, Inan. Please try to solve this question, Inan. That is in front of you. An object is placed in front of the plane mirror that is moved. Okay. What should be the answer from the given options?
sir, the questions. The question
An
now.
object is placed. Yeah.
The mirror is moved to a centimeter towards the object. Distance between the position of the origin and the image seen in the mirror is 2 centimeter, 4 centimeter. Sir, like, sir, 2 centimeters, right?
Solve it. Try to draw the figure. You try to solve the question using the figure in hand.
Okay, sir.
Yeah.
So 1 minute, I'll be back.
Yeah.
Sir, we should use the Miller formula in this.
No mirror formula. Only the properties of mirror. Plain mirror.
Okay, sir.
Because I've not basically taught the mirror formula yet. Right? So that's why. No mirror formula.
Sir, I did
Yeah, answer?
two.
No, Enaan. It's four.
Um,
Basically, you
Sir,
have taken only one side. Actually, suppose that actually the object was placed 20 centimeter from the plane mirror. Yes or no?
yes, sir.
So that means the image will also be formed 20 centimeter behind the mirror in an,
Yes.
right? Okay. So, but the object has moved 2 centimeter towards the mirror. Yes or no, Inan?
Yes, sir. So, like, how it is? Okay, the image formation only is 4 centimeters away.
No. The question is asking what is the distance between the image and the object? What is the change in the distance of the image and the object? It's asking that what is the distance between the original and the final image. So that was 2 centimeter from the mirror. Okay. So that means 2 centimeter will also be reduced from that side as well. So in total, 4 centimeter has been reduced. Yes or no?
Yes, sir.
Any doubt so far, Inan?
No, sir.
Sure, that's great. Okay. Please try to solve this question.
So scroll down a bit. I can't see the
Ah,
full question.
just a second. Okay.
So 2.5 meters away.
Could you please repeat?
The question, the answer is 2.5 meters away. He must
Very
walk
good,
like.
Inan. Yep, that's right. No. So basically, and actually, the object should be 2.5 centimeters. That means the object should have moved 7.5 towards the mirror. Answer is right, but the way of explanation is wrong. Answer was right. That means you were saying that 2.5 centimeter from the mirror. But that means the object should have moved 7.5 centimeter, 7.5 meter from the mirror. Okay, to the mirror, sorry. Clear, Inan?
Clear, sir.
That's great. Okay. Now there is a concept called number of images formed when two mirrors are placed at some angle. Suppose that in a two mirrors are basically placed at some angle. How do we find the number of images formed? Because multiple reflections will be happening. Yes or no? The reflection would be like this, like this, like this. Okay. So it's basically like that. So how do we find the number of images? The formula of this is basically 360 by theta. So theta is the angle between them. 360 is the total angle, complete angle. 360 degree, and after basically making the ratio -1. Got it?
Okay,
Good.
sir.
Okay, solve this question in an. What should be the answer?
Uh, 60, sir, 360 by theta minus 1.
Minus 1. Yeah.
Okay.
It's not like 360 minus 1. It's 360 by theta, then minus 1.
Uh, 5. Sir, 5. So the answer is 5, right?
Yep, that's the answer. It's 5. Very good, Enaan. Please do let me know, Enaan, is that clear to you or not till now?
Yes, sir. But we haven't been in this topic in school yet.
Ah,
Is it the refraction part or
no, no, it's reflection only now. We have not started refraction yet. It's reflection only.
uh,
Yep. Because refraction is basically half. Refraction will start after the half. Okay,
okay, sir.
we have just started the reflection. Okay. Now let's talk about the image formation by spherical mirrors in all. So basically, we have basically two types of mirror basically two types of spherical mirror. First is your concave mirror. Second one is your convex mirror. Okay. So now let's talk about first of all what concave mirror is basically. Okay. So concave mirror means that the inner part is the basically the polished part. That means light reflects it from the inner part. Yes or no?
Yes, sir.
Right. So concave mirror is also called converging mirror. Why converging mirror?
Because
Just a second.
when the parallel ray hits the mirror, it just converts the light ray.
So basically, concave mirror basically is called converging mirror because the reason is Inan is yeah, you are right. Basically, when the light ray is parallel, so all the parallel light rays is basically are pointed towards a single point. That is a focus. Clear?
Yes, sir.
Any doubt so far, Inan?
No, sir.
Okay. Next is concave mirror has a negative focal length. We will discuss that when we will do the what I was saying, the sign convention in the next class. I'll explain you that. But for now, just assume that it is just understand this thing that it is negative focal length. Clear?
Clear, sir.
Any doubt?
No.
Next is concave mirror always form real and inverted image except in one case. So only in one case it's basically okay. In only one case it forms virtual and direct images. Clear?
Clear, sir.
Chalo, that's great. Okay. So is that clear to you so far, Inan?
Clear, sir.
That's great. So Inan, these there are. Let's talk about the different points. First is your pole. Okay. This is the centermost point from which the principal axis passes. Okay. And after that, we have the next point that is your just a second. Okay. Next point that is your focus. That this is the point at which the parallel light ray converges. So distance between the pole and focus is called focal length. What it is called?
Focal length.
Focal length. Next is next point is your C. What is C basically? C is the center of curvature. Just like we have the center, the circle. In the circle, we have center. So in the spherical mirror, if you complete this thing, this is a sphere. This is a part of sphere. So when you will complete it, a sphere will be formed. And basically that is, so this C is the
Center
center
of
of that sphere. Clear, Inan?
clear, sir.
Okay. So basically, just a second. Okay. So C and basically and F. So that is your R, the radius of curvature. Because obviously, when you basically take the distance between the center and the circumference of the circle or the sphere, that is radius. Yes or no?
Yes, sir.
So in this thing, radius of curvature is equals to twice of f. So focal length is at the half of the radius of curvature. So it's valid for all the spherical mirrors. Clear, Inan?
Clear, sir.
Okay. So please note this down. I think that's not there. Please note this down.
Okay.
This draw this diagram and this thing.
Sir, finish. Done.
Finish. That's great. That's great. So basically, Nan, right now we don't have enough time. So what I will do is basically I will explain these ray diagrams in the next class. Right now, I'll just explain you the applications of concave, the theoretical portion. Okay,
Okay, sir.
okay. So that we can maximize this time. So now the first, okay. So now let me see that thing. So applications of concave mirror. So in concave mirror can be used for multi purposes, right? So the first purpose is basically your shaving mirror. So basically, men uses this mirror as a shaving mirror. So suppose that when they place a mirror like this very near to the face, the image becomes very enlarged. Because I've told you the one case, the image formed by the concave mirror is enlarged and virtual. Every time it forms real image, but in only one case, that is the virtual case. So that specific case is used by the men to shave their beard. Okay.
Okay, sir.
Second is concave mirror are used by the dentist to see the large images of the face or it's not the face, basically patient's teeth. Okay, Nan.
Yes, sir. Okay, sir.
Next is concave mirror are used in reflectors as basically in torches in vehicles. Okay, vehicle headlights basically to make a powerful beam of light. So basically, concave mirror can form a powerful beam of light. You must have seen that when you switch on the vehicle headlight, you basically see a very straight line going. Beam of light is
Uh,
going like this. Yes or no? We'll
yes,
discuss
sir.
that. You'll get to know that how it is formed in the in these ray diagrams. Every answer is there. Okay. So second thing about the concave mirror is concave mirror are used in the field of solar energy. So basically, we are basically going towards the sustainable energies, right? Yes or no, Inan?
Yes, sir.
So that is formed. Okay. So this is formed. The large concave mirror are used to heat up the solar furnace, right? Because concave mirror always basically you can say points all the rays towards a single point. Okay, that means it will heat up the furnace due to the
Yes,
sunlight.
yes.
Is that clear,
Okay.
Inan?
Clear, sir.
Any doubt so far, Divicha?
Uh, no.
Sure?
So, sir, in a concave mirror, so it
Hmm.
all focus on the principal focus, right? So
Yes.
the
When
image
the light
is
ray is
highly
parallel, when the
concentrated.
light ray is parallel, it will always focus on the. So there you go. Doesn't matter whether it's concave mirror, whether it's convex mirror, whether it's lens, convex lens or concave lens. All the light rays, for all the parallel light rays converges at focus. But you can see this thing in the concave mirror, the image formed at the focus is real. That's why we say that thing. When the light rays parallel, they converges at the focus like this. Okay,
Yes, sir.
got it.
Got it, sir.
And out so far.
No.
Please do let me know any doubt so far, Divisha.
Uh, no, sir. No.
That's great. Okay. Okay, let me explain the convex mirror part. Okay. So convex mirror is called diverging mirror. Why diverging mirror, Inan? Diverging means that light spread out like this. After reflection, light spread out. So actually, these light rays are not meeting, yes or no? Are they meeting?
They are not meeting with the
They
focus,
are
but
not
we
meeting.
are
What we have to do
assuming,
is
right?
basically we have to assume that suppose they are meeting behind the mirror. So that's why we
Yes, sir.
extend the line in the backward direction, and you will see that the parallel light rays again meeting at focus, but when extended. Okay,
Like when extended means.
means that it is virtual enough because actually they are not
Uh,
meeting. We have extended them in the backward direction. Yes or no?
yes, sir.
Any doubt so far to you?
No.
That's great. Okay, next is convex mirror has a positive focal length. What it is? It is a convex mirror has a positive
Po-
focal length.
Positive
Okay,
focal length.
yeah.
So,
Tell me.
sir, so it is. This is positive and concave is negative, right?
Negative. Yep.
So, so does it mean that object in concave mirror is down to the principal axis?
No. Focal length does not show that whether it's down or upwards. It shows that
Not, not sir, not focal length. The object.
object will always be upright. Doesn't matter which mirror you are using in on.
Okay, sir.
Object will always be
But the
upright. If
image form will be downwards, right?
image form will be down, up,
Okay.
basically inverted or erect. It depends what type of
Okay.
what nature of images, or what nature of you can say mirror we are using.
Ah,
Okay.
okay, sir.
Any doubt so far, Inan?
No,
Yeah,
clear, sir.
that's great. Okay. Next is convex mirror always produces virtual, erect, and diminished images. What do you mean by diminished? So diminished means smaller than the object.
Small.
It will always form virtual and erect. That means behind the mirror, as well as diminished images. Is that clear, Inan?
Clear, sir.
And out so far, division.
No.
That's great. Okay. So okay. So with this, our the convex mirror portion is done. So the infinity and the between there are two cases. I'll explain it in the next class. So now let's talk to the applications of convex mirror in Enaan. So applications basically first is basically we use the convex mirror as a rear view mirror. Okay. Why? Because when the light is spread out after the reflection, it gives a wild field of view. See this thing. It gives a wild field of view as compared to the plane mirror. When the light rays are striking, and basically coming back to the same with the same angle, right? But in here,
So
it's
so
basically giving a wide field of view.
that's why in rear view mirror when we see they say like it is much nearer than
Then the object,
seen.
yep, yep, and they're smaller. Actually, they are smaller. They looks very smaller now because the image formed by the convex mirror is diminished. Okay.
Uh,
Next is big convex mirror are used as shop security mirrors because they gives the complete viewing angle of the shop because the basically suppose the owner is not able to afford the mirrors, basically cameras, right? So that's why they will use